Hello and welcome to the next video. It's a devlog, and since it's not going to be viewed by the general audience, the GACHIMUCHI clips are back, baby. Putting the cart before the horse, there's something I need you to download and run. I did the forbidden technique of programming, and I need you to see if I can get away with it. Basically, if we remember my previous video where I said, I just memcopy. Yeah, I'm doing exactly that. And I need to know if I'm going to get screwed by Indianness or if I can get away with it. So the link to the repo and downloads, plural, are in the description. There are Windows and Linux versions along with an ARM64 Linux download, which hopefully you Mac users can wanjangle that into working. Let me know if it doesn't run. Either leave a comment or create an issue on the repo, and please include your OS and CPU. I know there are some combinations that will not work, but from my cursory research, it seems most modern consumer CPUs are a little Indian, and if I don't hear any complaints, then I'm going to follow through on that assumption. So, what exactly is the forbidden technique of programming? Again, I just baked the data structure I'm going to be using for my standalone GDScript LSP into the executable. This may sound fancy, but baking in data structures is actually super easy if your data structure is in a single contiguous allocation, my forte. Because after you generate the structure, all you do is printf the raw bytes to your desired source file. It's that simple. Now, why am I doing this? Well, if we all recall, last devlog I wrapped up by saying that I was finally at the point where I had to parse an 11 megabyte JSON file of the entire Godot API. Now, you may think it's a good design choice to just ship that file with the executable or tell the user to generate it themselves. I think both options are simply ugly. The former means you can't drag and drop the binary around freely, a hard requirement, and the second means telling a stranger on the internet to follow directions. I'm an American, and I know that simply doesn't work. The founding fathers didn't follow directions, and I'm proud to say neither do I. So that brings us to the little versus big Indianness. Super simple idea. Some CPUs represent numbers with the big figure at the end, so big endian CPU numbers are basically all reversed. Now, I am aware of this situation, and in my overflowing wisdom, I decided to not bake the data structure, but instead programmatically generate code that generated the data structure for the API, and then just run that at launch. Some people may call this metaprogramming, but this is also just old school code gen. So, long story short, I did just that. I ended up using the builder pattern, but with macros, which was fun, and it made sense since I would allocate an object first and then initialize it piecewise, which honestly, I feel vindicated to a degree. The builder pattern is neck and neck with dependency injection as my favorite design pattern, mostly because it lets me avoid constructors with dozens of arguments and is a solid argument for just make everything public, both of which I firmly believed in even before I became a C chauvinist. Seriously, just make everything public. Private won't stop me from grabbing that field with pointer arithmetic. One of my biggest gripes with C# is that it defaults to private, which is just a massive pain to work with. God, I'm getting distracted. But yes, old school code gen. It worked. One downside, I created a over 100,000 line source file, and that's with things being condensed with macros. It is so big, I could not compile it unless I used Emacs. My shell must have just thought it was a dead process and killed it by itself. It took me over 10 minutes to compile this single file, plus I didn't even try linking it. Now, 10 minutes, simply unacceptable. I'm going to make mistakes, I'm going to debug. Your boy has iteration in his blood. 10 minutes is simply too much for a single object file. Looking back, I could have split it up into a bunch of smaller files, but decided against that. Now, was I being tempted by the siren-like allure of the forbidden technique? Yes I was. But it was for a good reason. 10 minutes is too damn long. So, as I said earlier, I just generated the data structure myself and then serialized it into the source code. One important thing to note, I'm using the ultimate meme pointer. That's right, I'm using tagged relative pointers. Pointers do not get funnier than this. So, I'm using the least significant bits in my relative pointers as bit flags, and then just bit masking as needed, all to avoid using tagged unions, or affine types, or enums, terms, or whatever you type theory weenies call it. But the advantage of these hypermeme pointers is that I can pack stuff in super tight, since I'm not using tagged unions to differentiate between types. I'm using void star and just the last 3 bits. So yes, I have to run this program as part of the build process along with compiling, but ultimately it's a lot faster than 10 minutes. So that brings us back to what I said at the start of this video. Check the description and download the version of the program appropriate for your computer. Try running it, and if it doesn't run or some error pops up, let me know. Either leave a comment here, DM me on Discord, or create an issue on GitHub. Tell me your CPU and operating system because, as you can tell by the name of the repo, this is a survey. I want to know if I can get away with this devilish tactic, because if I can't, that means I'm baking the JSON with all the unnecessary white space trimmed into the program instead. So what's ultimately getting baked in? Nothing fancy, just a bunch of hash maps. I spent a bit of time thinking if there was a clever way to do things, but I came to the conclusion that I should just use hash maps. All of the global stuff, including operators, dumped all that into one huge hash map with over 1,000 entries. And then all the classes get their own hash maps. Honestly, this just seemed like the simplest solution. And I thought a bit about type checking while I was designing this, and hopefully this works well, especially for operators. Since Godot has overloaded operators for types like vectors, I was going to need a way to check, oh, there's an add with vector3 as arguments. Is that supported? So not exactly clever, just pop the operator and its argument types into the global hash map, and its return type is the value stored in the hash map. The one clever thing is I prepend the key with a space, since of course you can't use a space in a token. I'll let you know if this bites me in the ass. And as you can probably tell, I've been on a bit of a hash map tear. O1 lookup, can you blame me? So, having implemented many hash maps, I finally did my due diligence and added it into my tokenizer. So, just how fast is my whole parse process? Which is just tokenizing plus shunting. I was getting about microseconds on a file of about 80 lines. We'll say that's about microsecond per line. But 80 lines does not a rigorous benchmark make. So I did this sensible thing and wrote a GD script generated a just shy of 2 million line script. If we take a look at it, there's nothing actually going on, but it is massive. So how fast am I? Well, I'll make this a realistic-ish test aside from the size and all. So I compiled this at O2 with GCC, and I have my laptop in quote-unquote power saving mode, whatever that means. And I have my stats on screen right here, but as you can see, 11th gen i7, great, before the P&E core debacles, but again, of course, it's in a laptop and I have it on power saving mode, so it's undervolted. And now I'm hitting you with some numbers, but let's say 2 million lines in 1.2 seconds, basic division, bada bing bada boom, 0.6 microseconds per line. So at the moment, I'm under 1 million lines per second, whatever that means. I will try to keep it that fast, but you know, there's no type checking nor parsing user scripts, so I'm going to slow down. But again, speed is my #1 priority here. I can probably combine the tokenizing and shunting phase into just one huge pass now that I have the power of hash maps, since the dream is to just reparse whole files on keypress just imperceptibly quick, since I'm just too damn smooth-brained for piecewise updates. And if we take a look at my makefile, we can all see what's going on here. I've slowly but certainly sidled into the territory of makefile-based metaprogramming, which leads me to the side quest I took up last week. I joked with one of my friends about making a common Lisp build system. It just makes sense. As much as I love Make, it does have one problem in my eyes. The build system is not memey. Consider this macro, road trip, that I use for control flow. If you ever used F# or Rust, you should recognize this as just piping the output from one thing to another. But it's actually more powerful than that, because if we look at the macro definition itself, what I am actually doing is putting the result of the previous form at the end of the current form to evaluate, which is a subtle but infinitely more powerful difference. But, and this is the crucial detail, it isn't built into the language. I wrote it in half a dozen lines, as we can see here. That's what I mean when I say Lisp tosses you the keys and tells you to have fun. came to the conclusion that everything I want to do, I can thug out with Make, but most damningly of all, Make is just faster. Admittedly, I should be lazily evaluating more things, and I should make it work with general patterns instead of mapping in every file individually. Oh god, another bit of a tangent there. Anyways, just a reminder, please, third reminder of the video, download and run my baked binary survey. The link to the downloads and repos are in the description. Again, I need you to tell me if it doesn't work. Don't tell me if it works. It works on my machine. I need to know about your machine. Does it not work on your machine? That's what I want to know. And if it doesn't work, tell me your operating system. Tell me your CPU. That's what I need to know. I don't need your GPU, just OS and CPU. And second reminder, if you want the repos for recursive and parallel includes, it is also in the description. There are a bunch of goodies in there this episode. I said it once before and I will say it again. I am a river to my people. Dear beloved viewers, let me spoil you. And that's it for the video. Thank you for watching. I appreciate your time and have a nice day. If you liked the video, please give it a like. And if you want to watch the next video, which will be DIY nav mesh generation, please subscribe. This is the first of a few viewer suggestions that I've received, and I'm just gonna work through them in the order I got them. So I'm set for the next 4 to 5 months. And on another note, the holidays are approaching, so my next video will either be mid-December or January. And if I were a betting man, which I am, I'd put my money on January. And I think this year I corrected all my based misinformation in the preceding video, so no corrections for this year. Again, the comment section is open and the squeaky wheel gets the grease. I have got to know if you cannot run my goofy program. There's also a Discord server for the channel, another great place to tell me if you cannot run the program. Also a great place to make video suggestions and chat about anything. I'm trying to get everyone hooked on Clues by Sam, and I also post pictures of what I bake when I bake it. And speaking of baking, let's get to it. All right. So what we have here, this is actually it before I cooked, and a little bit of a mystery. It looks like bread, but not. This is not a bread episode. This is in fact a beef Wellington, and this is just it before I did the entire baking. As you can see, not very exciting. It's just all we see is puff pastry. But here we go. Here's the picture of it after I baked it. And as we can see, you know, this is the first time I ever made beef Wellington. So I didn't really do anything fancy with the, you know, because some people, you know, they do like cool designs with the egg wash and everything. And they'll do a second layer of puff pastry. I did not have enough. I did not have enough puff pastry for a second layer. But I mean, still, so yeah, just an egg wash, but still, second picture, it looks delicious. And let me just say, it was delicious. In fact, I think, I will say, this is the first time I did it. So the puff pastry was a little, let's say, raw, especially on the bottom. Because, I mean, you got the entire, what is it, a beef tenderloin in there? Yeah, you got the beef tenderloin on the bottom. I think if I ever do like this amount of beef, again, I'm going to like cook the bottom separately and then, I don't know, merge them together somehow. I don't know how. But yeah, we'll go back to the first pick because look at that. That's a looker. It's a looker. And I will say, my favorite part of this was definitely the mushroom duxelle. Oh my God, I loved it. I put a bit of tarragon in there. I think it's my favorite herb. Love tarragon. And by a bit, I mean probably a lot. And here's the pic of it, the inside. I took it to a dinner party, and this is all I had left, basically. As you can see, it's like a 1/12 of the original amount. But yeah, again, you're supposed to do it, again, you're supposed to like do it a little rare. But I'll be honest, you know, while there wasn't much left, the people who liked it, and that includes me, of course. The people who didn't like it because it was rare, they're like, oh, you know, kind of turn. It's a divisive. It was a polarizing dish. However, I was polarized onto the side that loved it. But yeah, my favorite bit, the mushroom duxelle. Like, Honestly, I could just the mushroom. I did have leftover mushroom XL, and I was so happy about that. Oh my god, it's delicious. But yeah, that stuff flavor packed. The puff pastry again, it's tough though, cause like it's big, you know. There's just so much mass. So like, I think I've made it like smaller ones following this, and I've like really focused on just like, okay, I make all the puff pastry myself. This is all by scratch, by the way. I think like the subsequent times, the few following times I've made beef Wellingtons, I'm gonna roll this out super thin, but I'm gonna do. God, dude, it's just it's a tough dish. It's a tough dish. And again, you know, don't call Gordon Ramsay. I didn't wrap it in prosciutto ahead of time. I'm not made of. Oh my god, dude. This was like in 2020. Yeah, this is 2023. It was a little price. The beef bag. I mean, beef prices. I mean, they've gone down slightly, but still. Oh, this was a pricey dish. It was a pricey dish, but it was delicious. And admittedly, I did trim down the beef myself a bit. So you know, it was like, oh my god, it was like over $100 of just beef. Delicious, worth it. But anyways, that's my this is, oh my god, this is like over 25 minutes. I gotta edit down. Oh my god. But anyways, I'm gonna sign off here. Even though I didn't use yeast, I did use butter, which is spiritually similar. Definitely not just as delicious. Not as healthy. Maybe yes, maybe no. Who's to say? Probably a doctor. Am I a doctor? No. So I can't say. Ask your doctor. Don't ask me. Delicious. Delicious. Just delicious. Also puff pastry. I especially like the trimmings of puff pastry because, you know, if I do like a palmier, I got the trimmings. I'm snacking on those bad boys. Basically, the beef Wellington is perfect. You get all these little snacky bits while you're working on it. You got the mushroom XL, even just the mushroom XL and the puff pastry. Ooh, slam it. Even if the puff pastry is a little raw, boy, you know I'm gonna. Oh my god, sign off. Oh, the yeast in the air is free, so go out there, bake. It's nutritious, it's delicious, it's good for you. And the final product of baking, not the yeast. You can't give the yeast as a gift. The USPS are gonna think you're shipping something else. Let me say that. But yeah, the baked goods make great gift and a great way to show people that you appreciate them. And I appreciate all of you. Thank you for watching, and I will see you next time.